Okay, here we are, Stats and Mechanics, Year 1, Chapter 11, Question 5. Particle P passes through point O and moves in a straight line. The displacement s meters from P from O t seconds after passing is given as s equals minus t cubed plus 11t squared minus 24t. Okay, find the expression for velocity of p. Okay, so velocity is when we differentiate. So velocity is equal to ds by dt. So velocity is equal to minus 3t squared, dropping the power, multiplied by the old one, okay, plus 22t minus 24. Okay, there we go. Meters a second minus 1. All right. Part B. Calculate the value of t at which p is instantaneously at rest. So we want to know where this one equals 0. Very clearly, it must be some sort of quadratic doing that. There it is. So if I actually differentiate this and get the acceleration, set it to 0 for that flat line, okay, we will have it. So let's do acceleration equals dv by dt, and so that equals minus 6t plus 22. Okay, and now I can set that equal to 0. It's equal to minus 6t plus 22, and so 6t is equal to 22, and t equals 22 over 6, which is 11 over 3. 1, 2, 3, is that 9, 10, 11? Yeah, 2/3. 3 2/3 seconds on that one. Okay. Right. A, B. Oh, next page. C. Find the value of t at which the acceleration is 0. Is that not exactly the same thing? It is it? That's what I've done for the acceleration there. I found the maximum on that last one, haven't I? So that was part B, but part C. Part B, calculate the values of t, which is where p is equal to 0. So I need to solve, I need to take this equation and set it equal to 0. 0 equals minus 3t squared plus 22t minus 24. It's all these people sending me messages, you see. Okay. Polysolver on the calculator. Okay. T equals, let's have a look. Right then, on to the polynomial solver. Number 2. What do we have? Minus 3, 22, and minus 24. Okay, t is equal to 6, and t is equal to 4 over 3. Right, A, B, C, D next. D. Sketch a velocity time graph to illustrate the motion of P in between 0 and 6 on your sketch. The coordinates points crosses the axis. Sketch that. Okay, well, I sort of almost did, didn't I? Right, let's have a look. So here it is. We know that it is going to 6. I don't think I need the. It's coming out to 6. It is also crossing here at 1 1/3. So if that's 6, there's 3. 1 1/3. So here, 4/3, 1 1/3. Okay. And I also know it's coming through here at minus 24. So minus 24. Okay. This is going to be T. This is going to be V. Okay. And then everyone's sending me messages. Right. And then the maximum actually is going to be at 3 2/3. So that's 1, 2, 3 2/3. So that was the 11/3 there. That gives me a maximum up there somewhere. And so now I can go from here, I can come up through that point, get to the top there, and come down like that. Did they want that value? No, just where it crosses the x-axis. Good, all right. And finally then, part E, calculate the value of t in the interval between which the speed of p is the greater than 16 meters a second. So at what point is it higher than the values of t that it is bigger than 16? So what we want to do is we want to take this minus 3t and all of that plus 22. So we want to say v is equal to minus 3t squared plus 22t minus 24. And we want to say when is that greater than, what was it? Greater than 16. So if we put it on here for 16 is equal to that. Okay, we can then get 0 equals minus 3t squared plus 22t. 24 and 16 get us up to 30, get us to 40, so minus 40. And then I can use the poly solve on the calc. Worth writing it in so the examiner knows what you have done. Okay. And then minus 3 plus 22 minus 40 gives us 4 and 10/3 and 10/3 seconds. So yeah, does it need to be given as a probably? Because it was greater than, we can say that it's 10/3 greater than t greater than 4 seconds time above 16 meters a second. Okay, that's 1. Honest. All right. Now do for that one.